Right. So we just talked about the 16 squared column and 16 to the third column pronunciations going across the chart. Now we'll do that going down the chart. Uh, Instead of reading fa, ta, va, da, etc., it just becomes a, taha, vaha, daha, paha, shaha, baha, jaha, saha, thaha, zaha, daha, kaha, chaha, gaha, jaha. All right, we are almost done. The only thing left is to go down the central diagonal and talk about why we have these special blue numbers. Okay. Uh, the central diagonal forms a really important exercise for practicing Fajora pronunciation and number recognition. And here's how it works. If I take the lower pronunciation value and then I say right after the upper pronunciation value, I form a Fajora word that is a Fajora number, and it's if I were to write those out in hexadecimal code, they would be very symmetrical. I've written the values in base 10 to help people with their intuition of what the numbers are. But for example, if I rewrote all these blue numbers in hexadecimal, the first one would be 4 zeros in a row, not 5. The second one would be 4 ones in a row, followed by 4 twos in a row, 4 threes in a row, 4 fours in a row, and you would keep going. When you got to 4 nines in a row here, the next one would be 4 A's in a row, 4 B's in a row, C's in a row, all the way down to 4 F's in a row. And anybody that works with computers will recognize that as how you mark memory locations when you're talking about what's inside the machine. Okay, now I will pronounce them because this is an exercise that you would do a lot of times. So I would say here just Afa. And this wouldn't get said very much because it's just an expansion of 0. But if I start here, you notice the number in base 10 is 4,369, a very important number in Fajora. Why? Because when you say it, you say Tahu Tua. When you say Tahu Tua, you are creating the equivalency for the consonants that represent 1 and the vowels that represent 1. You're saying the number that in base 16 would be written 1, 1, 1, 1, but 2 of your 1s are represented by the 2 T sounds, and the others are represented by the 2 U sounds. The modifications I didn't mention before, these little sounds here make sure that every odd number ends in so you can kind of keep track of odd numbers. Even numbers aren't quite as easy because you've got a, ang, eng, I, a, all, l. But anyway. So now I'll do the little exercise that you would practice pronouncing that goes like this. Afa, tahu tua, vahe ve, daho doa, pana pang, shanu shuna, bene ben, jano jona, saya sai, theyu thea, zaye zay, the yo doya, kala kal, chelu chura, gale gal, jalo jora. Okay, and literally when you say that, you are counting by 4,369s or saying elements of a multiplication table for the 4,369s column. So, yeah. But you are also memorizing the sounds that create all of the equivalencies for all of the basic 16 digits if you think of Fajora as a base 16 system. If you take each letter in its combined form, it's actually a base 256 system. But by learning the equivalency between the 16 consonants and the 16 vowels, it's also a base 16 system. And by learning the system of the flags and modifications, it can be a base 8 system, a base 4 system, and a base 2 system. So it can expand your thinking about a lot of things in math and computer science and so forth. Okay, that's it for this chart, and we're done for now.
Thank you.